Josep Salanova, and I will present this paper, The Cooperative Intelligent Transport Systems for Freight Transport. Evangelos Mitchakis is a colleague of mine. This work is presented the preliminary results of the simulation of one of the cooperative services that we're implementing in the logistics project. Some facts about transportation, about goods transportation, how important is it for Europe, or this high significance. Transport is consuming 1/3 of the energy in Europe, is related to a lot of employment and economic activity of the whole region. More concretely, the transport of goods is responsible for, what is significant from these facts is that the good transport is responsible for 72% of the CO2 emissions of the overall transport. And the freight, the goods transport it uses the road transport for half of the movement. This means that the reduction of the CO2 emissions in order to achieve the environmental targets has a good opportunity when providing ITS or ICT services to the freight transport sector. We have also significant congestion, which accounts for 1% of the GDP, which is related to the road transport. Then we should reduce this congestion, we should reduce these emissions, and a lot of technologies, a lot of services have been developed in order to achieve these objectives. In concrete, what we are trying in the logistics project and what I will present in this presentation, in this paper, is how to use cooperative services in order to reduce CO2 emissions, to reduce fuel consumption, also to reduce congestion, applying this cooperative service to the freight sector. Just to name two projects that have been done before the logistics projects in Thessaloniki and in Europe, and are the basis of the logistics implementation in Thessaloniki. The Eurydice project, it was related to the smart cargo, to the cargo items interacting with each other. And we had a demo site in Thessaloniki. The Trello project was the first one implementing the service that I will present you. The service is the energy efficient intersection service, which aims at providing speed advice to drivers of both cars and trucks, also buses, in order to reduce CO2 emissions, fuel consumption in urban arterials where we have traffic lights. This service was developed during the CBIS project, but it was implemented the first time during the Trello project. And we, as CERF, we were responsible for evaluating the vehicle systems. Finally, the logistics project, it started this January and is testing different services, cooperative services, applied to freight transport, both based on cooperative technologies but also in machine-to-machine technologies. This is a brief overview of the project. We have 5 core services: intelligent truck parking, multimodal cargo, eco-drive and CO2 footprint monitoring, and finally the priority and speed advice. And we are testing these 5 cooperative technologies in 7 pilot sites. One of the pilot sites is Thessaloniki, where we are testing the eco-driving support and CO2 footprint monitoring, the priority speed advice, and one more service which is not the core of the project. About Thessaloniki, Thessaloniki is the second largest city in Greece, with more than 1 million inhabitants. And we have 2 ongoing available infrastructures, one for the provision of cooperative services, which has been developed during the Compass for the project, and one platform developed during, I think it was during Eurydice, and after Eurydice, the Thetis platform, in order to provide integrated multimodal supply chain management services, which is being used by the Thessaloniki Port Authority. Some data about the Port of Thessaloniki, which is one of the most important ports in the Balkan area. This is the implementation of them in Thessaloniki. We have two use cases. In one of the use cases, we are testing the EcoDrive support to the drivers through a smart device and the monitoring of the GPS, and at the same time, the CO2 footprint estimation and monitoring. Our aim with this service is to reduce CO2 emissions. The other use case is to provide speed advice, which is the one that I will present you here, to the trucks that are passing by the intersections in Chimiski Street. Chimiski Street is one of the most significant arterials in Thessaloniki. Then there are a lot of shops there, and the proof delivery is being used by the truck drivers when stopping at the shops and then delivering the goods. The speed advice algorithm has been adapted by Surf-Hit, but it's based on the work of Parth and Borivon Somsin, which it takes into account the current position of the truck, the vehicle, the distance to the traffic light, the time to green, time to red, because there is a communication with the traffic lights, and we know the remaining time to red, the remaining time to green, and we can provide to the driver the advice to accelerate in order to get green light, to reduce the speed in order to get the green light without stopping. This is the main aim of the service, to reduce stop and go, which is one of the most significant parts of the fuel consumption, especially for trucks. Or just to tell you that you will find a red light, just try to reduce your speed in an environmental way. We will test this service in the real world, but this will start when 6 months to 1 year from now. What we did is to use micro-simulation model in order to understand how the service works, to have preliminary results, what we expect from this service, but also to try to understand if the service can be applied to the whole street or to the whole day. We want to understand, to define the implementation guidelines when and where to apply the service in the real world. The software we're using is AIMSA, which is a micro-simulation model. You can see here a print screen of the network. It's not the central business district, it's the Chimiski arterial with the surrounding streets. But we are we're building now the same model for the whole central business district in order to test the performance of the service provided to the whole set of traffic lights, not just to Chimiski arterial. And as the basis for building the scenarios, we use the morning peak period for a typical weekday, and we know that we have more or less a 4% of trucks in traffic flow of Chimiski. The environmental model is the one that is in AIMSA. It was proposed by Banks et al. And it provides both fuel consumption and emissions based on factors of the regression model, but based on instantaneous speed and instantaneous acceleration. We are analyzing all the trajectory of the trucks in Chimiski, and we are getting from this trajectory instantaneous speed and acceleration that we can convert into fuel consumption and emissions. As soon as we have real data from real trucks, we can apply the same models and calibrate and validate the model with real consumption data from the trucks. And these are the 9 scenarios. We have 3 penetration of trucks. We suppose that all the trucks are equipped, and then we have 3, 5, or 7% penetration of trucks in the traffic flow. We think that as more trucks we have, the reduction will be more significant. On the other side, we have different demand levels. This is very important because the provision of the service will have very different impacts and performance depending on the congestion level. We are testing low, medium, and high congestion levels. As you can see, the results are not good. These are the first results of the whole simulation. We are consuming more, 1% more, 1.3% more when we have high congestion. But these are just the first results. What we did is we analyzed the results per intersection, per route, in order to understand why we have more consumption, why we have less consumption. And it's very interesting because we found one of the intersections, one of the routes with these results. where we can see a reduction of more than 4% of consumption for low congestion and emissions. For low congestion situation, demand level, and almost 2 to 3% for high congestion level. The result that we want to achieve is not just this number, but we want to understand that this service for trucks can be applied to this kind of street with both geometrical and functional parameters. We need to understand if the distance between traffic lights has an impact on these results. If the congestion level has an impact, if the system will not work at high congestion level, we will not provide the service during peak hours, because we will know that it will not work. This was one of the outputs of the three-lot project. The system will not work when the congestion level is high. And this is what I think that should provide any project that aims at evaluating ITS or ICT, not just to find the benefit of the service itself, but to find the guidelines when this service can be implemented. What are the parameters that I should measure before implementing the service, and know that I will have the best performance for this set of parameters. I will have worse performance if the parameters are not this one. This is what we saw in Thessaloniki. For example, if two traffic lights are very close, the service will not work because there is no time to adapt the speed. Finally, and as a conclusion, is that cooperative services have been developed more focusing on passenger transport than on freight transport. Then here we have two solutions. There's to apply a small redefinition of the service and apply it to freight, as we did here in Thessaloniki, or maybe we should completely redesign the service, taking into account that I am providing the services to a truck, to the freight transport sector. And maybe there are other characteristics that I can take into account, that I can take advantage of, in order to provide better cooperative services for freight, not just applying the ones for passenger transport. I can see a relation between cooperative service and collaborative schemes. I think that during the last years there has been a lot of work in the freight sector talking about collaborative schemes. And I think that it should be, if not related, we should work together on developing cooperative service, but also using the collaborative scheme that has been proposed and developed. And finally, all this service should provide a holistic support, not just to the drivers, not just to the fleet operators, but a holistic service for all the actors of the freight transport, from the drivers to the vehicles, fleet managers, and network operators. This will allow us to have the best impact. This is what Logistics is trying to do with the 5 services, different services focusing on different actors, but all the services provided with the same platform, with the same objective. Thank you for your attention. If you have any question.